Alright, in our previous video, we dealt with definition of matrix. A matrix is simply an array of numbers. We looked at various illustrations of matrix, right? And we also understood that matrix has applications in solving linear equations, in transformation, and also in machine learning calculations. So let's quickly look at matrix notation and dimensions. The first thing is the notation. Notation, the matrix itself is represented by bold capital letters. Bold capital letters. So this can be A, it can be B, it can be C, up to A to Z. And this is what the matrix itself. However, the rows and column are represented by lowercase letters. So I can simply say that this is the matrix, and it can be X, Y, Z, A, B, C, and let's say P, Q, Y. All right, this is the matrix itself. We say matrix A has components X, Y, Z, A, B, C, and P, Q, Y. Now, to make it more sensible, we can say that matrix A is equal to A11, A12, A13, A21, A22, A23, A31, A32, and A33. Now, what does this mean in itself? So this brings us to the dimension part of a matrix. Now, a matrix in itself, let's say matrix A, has a number of rows, is a combination of rows and columns. Now, we denote the rows as M, we denote the columns as N. So if you want to read a matrix, we say matrix A is M by N matrix. Okay, now we know rows are like this, okay, and columns are like this. Now, if we take a quick look at A is equals to A11, A12, A13 down to A33, we can count the number of rows in itself, row, and we can also count the number of columns. Okay, we tag this as rows and we tag this as columns. Now, so we can say that it has 1, 2, 3 rows, and we can say this one as 1, 2, 3 columns. So if matrix A is given as A11, A12, A13, A21, A22, A23, and A31, A32, A33, that means we are saying that this matrix A is simply a 3 by 3 matrix because it has 3 rows and it has 3 columns. Now, so A, matrix A has the principle of M by N principle. Now, what is then this annotation of 1 1? We see 1 1, we see 1 2, we see 1 3, likewise we see 3 3, we see 2 3, and the likes. Now, so let's take, for instance, let's make this clear. We have A11 again, A12, A13, A21, A22, A23, A31, A32, and A33. Now, matrix in itself is annotated, let's say the element of a matrix is represented as Aij. That means if A is the matrix, the element is represented as Aij. If B is the matrix, the element is represented as Bij. Okay, if C is the matrix, the element is represented as Cij, and it continues like that. So let's put this aside and put it here. So now if Aij is a matrix, what is I? I is the row number, and J, okay, is the column number. I is the row number and J is the column number. So taking a look at this now, if you say A11 now, that means is the first row, okay, the first row, the first column. That means the element is located at the first row and the first column. All right. So and A333 will be the third row, okay, and the third column. Some people might just simply say row 1, column 1, okay, row 3, column 3. So row 1, column 1, row 3, column 3. So just like we perform our graph when we plot graphs and then we find the common points. Okay, so now if you look at this now, this is the first row, this is the second row, this is the third row, sorry, column rather. This is the first row, this is the second row, and this is the third row. So we can say that A22 is equal to the second row, okay, and the second column. Now let's take a look at more complex one. Let's look at A13, okay, A13 in itself. Let me perform the operation, this time more elaborate. A is equals to A11, A12, A13, A22, A2, this is A21, sorry, A22, A23, and we have A31, A32, and A33. All right, so we have row 1, okay, we have row 2. Let's remove this, it's quite useless at the moment. We have row 2, and then we have row 3. Let's draw this well. Row 2, and in the same vein we have column 1, and we have column 2, and likewise we have column 3. All right, so A11 is the first row, first column, right? First row, first column. Okay, now A22 is the second row, second column. Likewise A33, like we have seen, is the third row and the third column. Now let's take a look at this. I'll ask you, what is A12? A12 is here and here. So A12 is where? Pause the video and give it a try. A12 is in the first row and the second column. Likewise, let's look at A23. A23 is, this is the intersection, that means it is on row 2, column 3. Okay, row 2, okay, as it is column 3. Remember the matrix notation of the element as Aij, where I is the number of rows and J is the column number. Two more examples before I call it a wrap. Now A31, the intersection is here and here. So we have the third row and the first column. Third row, that's number 3, and the second column, that's number 1. And likewise A13, we can just depict from here that it is the first row, okay, and the third column. Third row, first row and the third column. Now this brings us to how this is the principle of matrix notation and matrix dimensioning. So in the next video we'll be taking a quick look at examples on dimensions and notations.